All right. So thanks everybody for joining today. We're going to talk about a lot about leak detection. We're going to talk a lot about how can we manage facilities differently. As Danielle pointed out, my name is Clay Rohr. I'm portfolio leader at Connected Solutions at Hussman. Something fairly new to Hussman. We dove into analytics back in 2019. At the end of the day, I've been at Hussman ever since 1999. I had a stint. I left and managed a controls company for a period of time. But at the end of the day, today I just really want to talk about, how do we change from going from the way we manage facilities over the past 100 years to changing the way we manage them. Okay. I think from my perspective, what I was really looking for whenever I was trying to buy companies, buy technology, test technology, as we got started into this, was just how do we get better at using data to help technicians do their jobs better and more efficiently? How do we really manage our overarching facilities in a different way? Because the problem was we were never continuously improving because things got more complex, more problems arose, and we're going to talk a lot about the problems. And as we've developed and partnered and really worked through this technology, you can kind of see by the numbers. This is probably 8 months, a year old, but as we rolled this out across a lot of our contract sites, we were able to save ourselves over $3 million just over in the past, year and a half in refrigerant leaks. Okay, because we manage a lot of facilities, we're responsible for the leak rates, we're responsible for compressor failures, we're responsible for downtime. Right. So at the end of the day, we feel like using advanced technologies helps further the cause and using data to prioritize things. I'm going to kind of jump into the problems here. All right. There's lots of stuff coming at us. Everybody knows AIM, CARB, the state level regulations are all hitting us from every angle. We've got to do new things, different things, lots of different standards to follow. Those things are always creeping up and helping us drive and continuously improve. Material inflation has just went crazy. So we've seen a big jump in 2020 through 2022 in refrigerant prices. Now they've kind of leveled out. What I am seeing is that whenever we start to reduce the production of certain HFC refrigerants, that will increase again, much like it did in Europe. Most people have seen that study where it continued to rise to where it became a huge cost to retailers trying to utilize HFC refrigerants. Okay. And then one of the biggest things that we're seeing, there's the cost, there's the regulations, but technician gaps are just a huge problem in our industry. We're projecting 225,000 in 5 years. Okay. And it's just a problem in our industry getting folks that want to work nights and weekends. At the NASRC, we talk about it all the time. How do we increase participation from high schools, middle schools, getting kids back interested into HVAC and refrigeration? Whenever I was in high school, I was like, oh yeah, that's really neat, and I became an HVAC tech, while I was in engineering school because that was the thing to do. And since then, it's that's not the most popular thing to do. So how do we increase that level of engagement with technicians across the industry? As we dive into this, so what is a cost? What's the cost of leak rates? Okay, you look at the average leak rate across the United States at 25%, at around a 2,000 pound charge for all the systems in the store. That's around 500 pounds per year. If you take the average cost of refrigerant that you pay through your contractor, through your vendors, around $25 a pound, right? By the time you balance out your 404A, some people have R22, and then, of course, 448, 449 are a little bit less expensive, right? So you could have a leak cost you around 12,500 per year in just leak rates, okay? And then you think about, downtime. If you don't detect them and you run your tank empty, you run your system out, you're going to have downtime. Is that one meat case? Is that one frozen food case? Or is it a whole lineup? You could lose up to $10,000 and just trying to get that back up and running, recharge, figure out what the problem is at the site, because nobody knows when it's down until they get there and start diagnosing the problem. It can take hours. And if you really think about it, you look at the scale of this problem. If you look at the right there, the EPA the average supermarket leaks 870 pounds. Okay, whenever you take that, that's equal to 339 car emissions in the atmosphere every year. Okay, so that's one store, one 875-pound leak is 339 cars running all year long. All right, that's 1.5 million metric tons of CO2 equivalent emitted to the atmosphere. All right, so we got a pretty big problem here. We all know it. We've all tried to manage it over the years, and at the end of the day, we've just got to do something different. It's not the easiest thing to solve because there's miles of pipe and lots of problems and where to find the leaks across the facility. If we look at kind of what's upcoming in the AIM Act, okay, what this is really telling us, the subsection H portion of the AIM Act, leak rates above 20% require leak repair. Great. All the way down to 15 pounds. Whenever you have a system that has over 1,500 pounds, you have to use an automatic leak detection system starting in January for new systems, and then existing facilities in January of 2027. Okay, so you got some time, but at the end of the day, this is something that's going to be mandated throughout the AIM Act regulation. Okay, and you have some decisions to make here. There's two different solutions that you can use in the market. Direct systems, where it's a sniffer, you can get multi-zone, single zone. We use a lot of multi-zone leak detectors in walk-in coolers for safety, as well as rack rooms, to find those major leaks and help our technicians get to the leak locations quicker. And then, of course, the other option is an indirect system. And that's a lot of what we're going to talk about today. But an indirect system measures the entire leak rate of the system and tells you how big that leak is and lots of other stuff. The big difference is a direct will detect a leak wherever it's sniffing. So within a refrigeration system room, an HVAC system, if you can get them all over the store, lots and lots of points, you can detect leaks, even down to the case level. With that said, both work well tandemly together because one gives you the leak rate, gives you the prioritization to go out and roll trucks. Direct gives you, hey, you need to go to the rack room and start there. There's your biggest problem, right? So what we're finding in across predictive solutions versus reactive maintenance, waiting until the refrigerant leaks out, we typically find around a 40% refrigerant usage reduction in year one, okay? And what that really entails is I'm going from, that 2,000 pound charge, losing 500 pounds of that, almost losing barely 300, 250. And you can continuously improve on that. After year 2, year 3, we're seeing that you can get up to 50 and 60% refrigerant leak rate reduction because it's just all about how you manage the process. Okay. So what does that mean? Well, proactive alerts helps us fix leaks sooner. And I got some slides on that. But at the end of the day, if you detect very quickly and it's not noisy and you send a truck and you fix the leak before you lost 20 pounds, it's a big savings. Because if you got to wait until you lose 200 or 300 pounds, all of a sudden you spent a lot of money before you took action, right? One other thing that we found is that instead of doing periodic leak inspections, either quarterly, biannually, or annually, you can use the system to do that because it's always telling you your leak rate across all stores. And that's a pretty big savings. You look at your latest labor rates across, leak inspections. I'm probably kind of lowballing that, to be honest with you. Just depends on the size of the store. But going out and doing the leak inspections are a big labor pool and takes a lot of time. And we don't find, the leak reduction if we just do the periodic leak inspections. We use the technology, the data to drive the leak rates across the fleet, and then we focus those leak inspections on the biggest leakers. Okay, and then all of this types of technology qualifies as an automatic leak detection system for the AIM Act, as well as for Washington State, New York, and CARB. So here's the problem: if you do nothing, you're going to be probably across your fleet around 25% per year. Now there are people in the industry that do a lot better than that, without ALDS. They go out and they do very regimented leak inspections. They do very detailed looks at the data. They pull the controller data. They do their own views and calculate their own leak rates, trying to get at that level of leak rate reduction. The problem is that takes a lot of people, very manual, right? But the industry average is still 25%. If you look at slowly repairing leaks, right, it's always going to give you a higher leak rate. And on your really leaky systems, that gets really big over time because you're not staying on top of those leaks. And all of a sudden, we sent a tech. Yep, didn't find the right leak. We didn't find that out until 6 months later. So now we've lost another 250, 500 pounds, right? I've lived through this many, many times over the past 30 years. But at the end of the day, there's ways to kind of help compensate for that. Periodic leak inspections, you need to do it depending on which regulatory body your stores are within. Every 3 months for systems above 500 pounds, every 12 months for systems 15 to 500 pounds. And then, of course, you're going to have the mandatory ALD on systems above 1,500. All right, done with the marketing slides.
Clay,
so now we'll get into my world.
For you.
Yes.
From the Q&A. A common issue we've heard in the industry is that AI leak detection has a big problem with false and nuisance alarms, which ultimately requires you to spend a lot of time sending your contractor to do manual inspections. Have you found that to be a problem with your solution?
With our solution, starting out, yeah. Back in 19, 20, even 21, we spent millions of dollars to reduce noise, to be honest with you. And the way, and I'm going to show everyone how we measure that and how I would advise you guys to test different technologies that you're working with. What you're really wanting to do is ensure that you got at least 85% accuracy. So you want to measure the number of truck rolls versus the number of leak fixes. And I'll explain that question in far more detail in about 3 or 4 slides. And then I'll answer your question in a holistic manner. But yeah, at the beginning, I seen this technology fairly noisy because a lot of different folks, I invested in it since 2010. At the end of the day, I think a lot of other folks have invested in it longer than that. And it just gets better and better every year. I've seen a leapfrog change in really getting more and more systems into the market and getting feedback to improve accuracy. There's so many different types of systems and where refrigerants used, but I'll explain that question a little bit further, Danielle, whenever I get to probably 3 or 4 slides from now.
Okay. And then there is a question, a hand raised. Do you want to take that now?
Yeah, of course.
Okay. Isaiah, you should be able to unmute yourself. I can't unmute you. You'll have to unmute yourself if you want to talk. Oh, maybe not a real hand raised. Okay. Sorry about that, Clay. Continue.
Oh, no problem at all. Gives me a coffee break. All right. So what's the problem? We went back, we talked about, what do we do today? We got a 25% average leak rate. Why can't we manage these? What's the true problem? Now, I put an extreme graph up here. All right. I'll be honest with you. Not every store is like this. Not 50% of the stores are like this, but I have seen this in a certain percentage of stores across our stores that we manage. Okay. And what this is, I call it, you don't have data to help drive continuous improvement until it's too late. At this is probably 8 months of data. You see the technician added charge 1, 2, 3, 4, 5, 6, 7, 8 times, okay, over this time period, putting in 175 pounds, keeping the system above 10%, right? And what this retailer did is that they would roll a truck on my liquid levels at 10%. We need to go and add refrigerant and find the leaks. They never found the leaks, okay? and really what the majority of the problem is, you could say it's a bad tech. There was probably 4 different techs that probably went to this site to add refrigerant. It isn't all about the technicians, okay? Here's what happens in the real world of servicing a whole bunch of supermarkets is that you just don't have the time in the summertime. Okay, and this was a lot of summertime activity. Um, you you really don't. You have miles of pipes to check, right? And you have certain limits on time on how long you can spend in trying to find these leaks. You got emergency calls where cases are down at another facility, and you got to go get them fixed. It just really limits their time and how much they can go out and find a leak. And so what I find across the industry is that we go out, we add refrigerant, get the system back up in spec, and then we do a quick leak inspection. And the only unfortunate part about that is that we usually don't find the right leaks, okay? Because the technician doesn't really know how big the leaks are, right? They know that they're down below 10% or they're at zero. They've leaked the refrigerant out. They don't have the history typically of how, whenever that how much refrigerant they've used over the past 6 months, 8 months. They don't know how big the leaks are that they're dealing with because they just got dispatched to the facility. They've got to go out and get this thing running and repaired. And the last thing is they don't really have any feedback whether they fixed the right leak or not. In a couple of slides, I'll show you an example of where we sent techs and they continuously found leaks and continuously improved, but they never did find the big one until the third trip because it's a very difficult job whenever you have 5 miles of piping. Some of it's 20 feet in the air, some of it's underground. Sometimes you got to shut cases down after shoppers are gone and let them kind of stabilize and see if there's any leaks in the cases. Leaks can be in a lot of places. So that's the real problem. And my takeaway from this is that without a data driven model, okay, you don't really have a good way to manage and continuously improve your leak rates without a lot of manual intervention. And I think that's the continuous problem. We have 42,000 supermarkets. There's just not enough people to go out and examine all this data and understand and help those techs know, how big a leak they're looking for. I think that's why we have to automate the entire process, right? So in a graphical, nice marketing slide, you can tell I didn't build this because it's really nice. But at the end of the day, whenever you look at the way we manage leaks today, even if we're documenting all of our charge ads, we're going out doing the best job we can. We may find a few leaks in that first trip. I'm following that top arrow. So the first trip, I find a leaky Schrader, a leaky ball valve packing nut. Next trip, I find a compressor service valve. I tighten it. I make sure that it's correct. And then the last one, I may go and and fix a cracked pipe, or perhaps I've got a major issue on a condenser where I had to go and actually braze and repair something. Over that time frame, on average, if you look at the 5 to 8 month window, that's when we're getting to those leaks and getting them fixed, just because of the noise in all the problems across our industry. We've got to get them fixed, got to get them fixed. And in the winter around this time, we have more time to do those deep dives on leak inspections. And what you do with, predictive technology, okay, is that you can get an early detection. All right. The requirements are less than 2% or less than 50 pounds lost in your tank, right? That's really much better than the top line. And honestly, you can beat that as long as you really look at and optimize your condition based maintenance model. All right. And a lot of times, I'll tell you, there's a certain percentage of the time that they don't even fix the right leak the first time. Whenever it's watched with a data model, it takes another trip because, hey, sometimes there's 4 or 5 leaks at a facility and they think they fixed the right one and they don't. But then you get that call back, you get that data quickly, and you get it fixed within the first month or two. That's just money in the bank for the retailer, because at the end of the day, you're not sitting there waiting 6, 7, 8 months before you get to the root cause of the problem. So let's talk about this, and then I'll get into the accuracy types of information. Okay, I'll kind of explain how automatic leak detection systems work. At the end of the day, they detect leaks early, and they're looking at where refrigerant's used in the system. They're calculating out all the noise. So the question on noise, one of the things to do is you've got to get rid of all of the thermodynamic properties that are affecting the system, whether that's the ambient capacity, you're looking at the utilization of on your condensers, delta T's, all the way through the entire system. Because what you're trying to do is figure out how much refrigerant's being used by that system. Because what's not being used should be in the tank. And the way ours works is that we compare that against the tank. And that tank level, we calculate where it should be versus where it actually is. And that deviation gives us a leak rate. And that leak rate, being 85% accurate, helps us understand the priority of when to send a truck. So the bottom graph on this chart, the bottom left graph, it just tells a story. I'll tell the story, the graph may not tell it. We detected a leak. We were losing like 200% leak rate at this facility. And we installed this technology way back when. And I dispatched a technician, had them do a deep leak inspection. They said, thanks, Clay. We found a couple problems, found a couple leaks. We really appreciate it. And what we did is 10 days later, it triggers and says, hey, this leak isn't fixed. So send them back out. They went back out to the facility, and they took a couple senior techs with them, and they found a bunch of leaks. So you can see they went from that 200 or 150% leak rate to about a 40. And they're looking at the data now. They have logins to the system like I do. And they said, Clay, look how good we did. I think we got it fixed. And I said, nope, here's the problem. When a technician's looking at, whether it's Emerson, Danfoss, or Microthermo, or RDM, all these systems are giving you a liquid level. If you're looking at a small window, it doesn't look like you have a fairly large leak, right? You just see a very small change over a shorter period of time. What that curve actually shows right above too late, receiver close to empty, is a 40% annual leak rate. So I said, nope, we got to send them back out. And this is one of my friends. He's a senior tech service manager, actually, and goes, what do you want me to do, Clay? Rent an overhead lift and go to this facility? He said, I went with him, and I just don't think it's leaking. I think your software is not right. And I said, you're just going to have to rent that $350 lift and go and check overhead piping. They called me the next day. Sure enough, there was corrosion in the overhead piping. They had to replace 80 foot of pipe. And then you can see they're much lower than a 10% leak rate on an annualized basis. The reason I tell a long story like that is that it is the real world. No matter if you're using ALDS or just trying to continuously improve leak rates at a facility, data is king. And then the question that someone asked around accuracy and noise, there lies the problem. If you have a noisy system, if you have noisy data, and it will create, the technicians won't trust it, you won't trust it, and it won't work. And I'm going to show you a few ways to manage that with no matter whose ALDS system you ever use, okay? But at the end of the day, it's all about putting validity and trust in the data and continuous improvement. Because once you find it and everybody understands how it works, you get that continuous improvement in these facilities. Because this was just one example. I'm going to show you examples across 200 stores to where we were able to reduce leak rates by continuously focusing on that, the top 20% leakers across the fleet and continually improving those. Okay. Here's a little bit deeper example. This one's an old one from 2021. I always leave it here because it's a great example of why I always recommend both sniffer technology as well as ALDS. So that picture in that graph is a lag screw on a liquid line. There is a really nice sniffer unit in that room. But that problem with that liquid line is that it was right by the exhaust fan of that rack room, and it was pulling all that refrigerant out the wall. So what ended up happening, the vibration on the liquid line ended up leaking all the refrigerant out of the system. Not all of it, but you had a fairly large, 10%, 5% leak rate per day. And we triggered it quickly with a algorithm that looks at very fast leaks. Say, hey, we got to get somebody to the site. We were out there within a day, got this fixed. And the retailer's like, oh man, we would have lost the whole charge in a couple weeks. And the thing about this is that you're able to take proactive action because you have the accurate data, because you have a data stream helping you manage your business, right? And the thing about this is that the confirmed fix is very important, as you can see from the last slide, because if you're not confirming that you're fixing the right leaks, you're just going to continue on and you're going to continue to leak because we didn't find the right leaks. All right, so this is a case study across 3 different retailers across probably 3 years, around 200 stores. What we did is we always establish a rules of engagement. All right, so I don't mess around, and I'll recommend this at the end. But whenever I'm testing technology, you want to establish rules of engagement. You want to define what trucks are going to roll based upon what issues you want to find. Okay, for leaks, these customers said, I'm going to roll trucks on critical leaks above a 20% leak rate. Okay. So these customers are automatically, if I hit a 20% annualized leak rate, I'm going to roll a truck. Now, one retailer would roll a truck the next day. The other retailer would roll it within the week. And then another retailer was within, 4 or 5 days. All right. That was the rules that we abided by within the leak side of the business. Okay. Across these 200 stores, we were able to get them all. One was 39, one was 41, and one was 40. And the only reason I share this is it really surprised me that they were that close to the average. It wasn't like one was 60% reduction, another was 25, and they averaged out to 40. They were all within 1 or 2 points of refrigerant reduction. And this is not what I'm going to show you on the next page. This is from their refrigerant addition data. So whether they use TrackRef, Verisay, et cetera, to measure their leak additions, that's how we measured that. And then when I'll show you how we measure it, but we measured leak rate accuracy of 85%. So the question around, the noise in these systems, this is what I'll teach you how to measure so that you can hold the software, hold everyone accountable. It'll help everybody improve over time because this is how we started. In 2020, 2019, whenever we started this out, we measured every truck roll. And I'll show you how we did that in the next slide. The other 10 to 15%, there's always 5% that's like, oh, the valve, the split valve was broke or heat reclaim was locked on. Because as soon as you assume the software, all it does, no matter what you really look at, it's assuming that whenever a valve is kicked on, that function is going to occur. Okay, so a split valve, whenever it's clicked on, it's going to drain the refrigerant out of the split side of the condenser, and it's going to be in the tank. Or vice versa, I open it up or I close it, then I'm going to fill that condenser. That's very noisy, okay, if that valve doesn't work. If the valve works, then you're perfectly fine. So you find a lot of that, not a lot, but, let's say 10% of the time you find that. And then there's a certain percentage of the time that, software can't be necessarily perfect in these big stores that have lots and lots of circuits where, hey, we've seen a blip and it may have been somebody servicing the unit, shutting stuff down. A case could have been shut down. There's lots of reasons, but typically around 10% of the time, you're going to send a truck that's going to go and try to find a leak, and they're not going to find a leak. And then the software is going to tell you, hey, you went back to good. And everybody's working on continuously improving that. And I'll tell you that it's not impossible, but it's going to take a lot of data to continuously increase that accuracy over 85%. Just because I've seen so many, because I personally, for a couple of years, I personally looked at it. All right, what's our problem here? Let me help these data scientists figure this out, right? And at the end of the day, some of it is just normal actions taken that you've got to understand from how they're using equipment and how they're adjusting merchandising and things like that. Because all of a sudden you shut down a case, all that refrigerant boils off, gets back in the receiver, or it doesn't, right? It's trapped in the case, and all of a sudden you're like, oh, looks like I might have a leak here, but it really wasn't. So let's talk about how we measured this over the last 5 years. All right. What we do is every work order that goes out, whether it's dispatched to Hussman, whether it's dispatched to other contractors. We measure every asset, every work order, and we follow it through the process. So as you could tell from those graphs, there were different inflections in time. There's different time stamps on our methodology. And at the end of the day, we measure, there's probably 5 algorithms we use to catch leaks. There's different layers of accuracy. There's also different jobs. We have stuff for super fast leaks. We have stuff for super slow leaks. We have stuff for intermediate, because it's all about, in my eyes, whenever we develop this, it's all about really picturing and understanding where you're at in your leak rate journey. You know, if you have a super leaky facility, it's really easy. Go out and fix the big leakers, right? Whenever you're, you know, a lot of our customers are Green Shield partners, and they're trying to get their leak rates, you know, below 10, below 7. They have really big goals in mind, and you've got to really ratchet this down. And the way to truly measure it, to reduce noise and to understand, you know, if you're wasting money or not, because this is all financially based, right? When I rolled a truck, did the technician find the leaks? What did the software say after the refrigerant action was taken? And that confirmed fix or not confirmed fix, we measure that. So we'll measure the amount of misses that we see. We'll measure the amount of go backs a technician has to make. And when I partner with retailers, I tell them, you can't take that against the contractor, especially one go back. I mean, you're talking some of these facilities with these miles of pipes and how many valves are out there trying to find a leak. And there's certain limitations that retailers put on contractors, say, hey, go spend 4 hours and see if you can find it. Sometimes they need more time, so they have to go back. But once we start measuring go backs, and if that goes up too high, then you start to manage go backs. You say, okay, why are we having to go back to this site? What did you find on the first trip? Because it's all about continuously improving. What I look at this as, some technicians told me early on, they felt like this might be Big Brother. And I said, no. I said, this has got to be a partnership with the technician, the retailer, and the software provider. And what they've got to do is work together on continuously improving, because nobody knows everything. And now you got a data set that everyone can gather and manage around to get leak rates down, to get compressor failures down, and to improve condition-based maintenance. So the metrics that we measure, again, help us continuously drive and build credibility into the data, build credibility into the software, as well as really round out and help optimize and continuously improve the process. Because here's something I'm going to tell you that you probably don't expect me to say. The software is probably only 30% of the game. You need the data, but now you've got to build it into your existing processes, and you've got to put priority on it. With that said, what do I expect out of retailers? Guess what? Retailers don't need an engineering degree to manage this side of the business. What I really ask retailers to do is look at the high-level reporting and hold everyone accountable, including the software provider, okay? You want to look at your leak rates across those facilities. You want to look at your dollarized risk, and you want to say, okay, this is what we put on our software, right? I don't know what everybody else does, but we measure days in current status. We measure GWP potential risk. We measure estimated dollarized risk, as well as leak rate. And this gives you a business case to roll trucks, but it also gives you a business case for the retailer to say, this is worth my time and going out and seeing what's going on with these 3 stores, right? Okay. And I never look at anything that's older or newer than 10 days, sometimes 15 days, depending on how many stores I have this rolled out across. And the reason is it takes time to take action. Because if you automate that routine I talked about, I'm automatically rolling trucks, I'm automatically doing the leak inspection, and then I am confirming that I fixed the right leaks. That should handle a multitude of the process. And then you'll get the data, the retailer will get the data. Here's the go backs, here's your confirmed fixes, and here's where the software failed. And then they have the power with all this data to say, okay, let's hold people accountable. And that's the job you got to do. And it doesn't take very long, because if the data is served up to you, all you have to do is make a few phone calls. We typically have a meeting per month. Sometimes when we're getting going, it'll be every 2 weeks, sometimes every week, depending on the retailer, where we'll review all the data and ensure that things are happening. Because as you'll see in my closing statements, it's a lot about taking action and focusing on, on that data to make sure you're getting the results. Once everybody gets it, you're in good shape. Just to pepper in what the other goal I had whenever looking at technology like this, I probably tested 5 to 10 different technologies over my career, was how do we get out of the break fix model? Okay, so we talked about leaks in depth. Everything else works like leaks. It's just a different equation, a different problem. Okay, do I have all my cases optimized? Do I have my systems optimized? Condensers, display cases, etc. This technology and technologies like it are all about pointing out anomalies. Now, what I'll tell you is that there's probably a handful that I automatically roll trucks on problems. Okay, when I've got some critical case issues, I got critical leaks, critical compressor health, and just a couple others. All right, everything else I put it in my mind as a condition-based maintenance model. Okay, what does that mean? Well, condition-based is I have a bad condition, I have a bad health, I have a score that's going against the operation of my equipment. And what we do is that we calculate down to a certain level and say, boom, I'm going to send a truck. And guess what? I don't send that truck in the middle of summer. I send that truck from September through May because I don't have enough technicians to deal with it in the summer anyway. At the end of the day, we go and we'll roll a truck based upon a low health of an overall facility. So what does that give me? Well, I'm rolling a truck based upon 5, 10, 15 problems at a site. So now we had a question earlier about noise and issues at a site like, hey, I hear they're really noisy and lots of problems. Okay, great. The one way to solve that is to roll a truck on more than one thing at a time. Okay. I wouldn't tell you to do that on leaks, but on everything else, if you go and you have a list of 10 issues and you send a truck to fix those 10 issues, I will guarantee you 5, 6 of those 10 issues would have resulted in an emergency dispatch of a truck a month, 2 weeks, 3 months down the road and cost you money. Okay. So we've done this study across quite a few retailers. This is one retailer that we manage all these facilities. It is husband service, but we were able to get that 38% decrease in refrigerant leaks. But look at the decrease in the number of service calls per year, a 38% reduction in doing what I just said, calculating the risk at a facility, sending a truck to fix multiple things at that facility at one truck roll, and then measuring the improvement of the health of that facility and maintaining the health of that facility. We were able to reduce their service calls by 38%. Their average invoice cost by 22%. So that's not just total service cost, that's average invoice cost. So the cool part about this for this retailer is that they got the leak rate reduction. That's why they partnered with us, right? And then we were able to get them service savings, and we were able to reduce their headaches throughout the year by continuously improving these stores. It does change the dynamic if you do it right, okay? That's the one thing I'll promise you, is that if you focus on this, it will reduce emergencies. It will reduce those summertime headaches. You're still going to have compressors that fail. You're still going to have major pipe breakages that cause major leaks. You're going to have valves out of adjustment. But if you stay on top of this, it's the 80-20 rule. You're going to get a drastic reduction in your emergency calls, which gives you a drastic reduction in your cost. Okay. So just real quick, talking about ways to pay for this. We've done this with quite a few retailers. The carbon credits, a lot of retailers tell me it's funny money. At the end of the day, it's like the stock market. All right. Somebody needs to reduce their carbon. So they buy it down by using your benefit that you're not using to reduce their carbon emissions. Okay. Well, why not take advantage of that? So if you're going to get a new construction for a new CO2 system, anywhere from 58 to 95,000, HFC to natural conversions, similar range, leak detection, anywhere from $8,000 to $30,000 over 7 years, just doing a great job at leak rate reduction. If you're going to do retrofits to 448A, you can get 10 to 35K. This all depends on where you're at in the country and all that stuff. Your reclamation and ODS instruction, anywhere from 15 to 35K. We don't find it as funny money. I look at it as a stock market. You're just moving. You're making improvements at your facilities. They're taking advantage of it for their shareholders, and at the end of the day, it's a win-win. And we've seen it work across multiple retailers. I have one retailer that's over $600,000 in benefit over the past year and a half. So it is real. All right. My goal was to go 30 minutes, and I'm already 40 minutes, so I better go quicker. But one thing I'll tell you, before you begin and go out and test ALDS, just understand there's no identical stores. There's no standards. Some of these stores are older than me, and some of them are brand new. They all have, a lot of them have different controllers, different sensor layouts. They're all designed differently. There's a few retailers that do a good job at, cookie cutter, but, retailers are very focused on, creating a competitive advantage. So things have to change. And that's why, you've got to wrap your head around that. There's limited standardization on sensors. Okay. So always check that. We've rolled out across some retailers that they said, yep, I've got liquid levels, I've got the right temperatures, I got the right pressures, and they didn't, right? They were just older stores that didn't control based upon that. So that's something to look at. The number third point, outputs or events derived from data must be actionable for a technician. It's one thing that's got to be important. I've tested so much technology, and you can't just tell them that it's a case temperature problem or it's a pressure problem. You want to partner with a technology that gives the technician a very good playbook on what's going on with that issue, with that whatever that may be. Temperature out of range, whether that's an issue with the compressor protection. You want to have the detail in there for the technician to make them quicker, faster, understand it, and be able to get to the root cause quicker. All right. And then, as we already talked about, these actions, you want to track them against the data. You want to do it to improve algorithms. You also want to do it to improve your processes and procedures, because it isn't all about the software. Realize that's not the big piece of this. Is it just really changing the way you manage facilities. You're using the data, that's for sure, but the way you manage and process this throughout the organization is the way you actually make money. All right. You want to, even if you're testing, you want to work towards automation. All right. And you want to embed workflows and even escalations in your work so that you understand what's taking place across the fleet that you may be testing. And then last but not least, and I'm not a bullet reader, that's why I'm bad at slides like this, but you really want to look at training for everyone involved. Don't leave out the store manager, don't leave out the contractor, don't leave out your boss. Get everybody involved in what this is going to do, how it works, and what the expectations are. All right. And then my takeaway from this is the best data without actionable outputs is similar to having a great strategy without execution, right? How many strategy sessions have you been in and you didn't take action on it and it never happened? It may have been the greatest thing you could ever done, but if you don't do anything, it doesn't end up resulting in anything. So leads me to my second to last slide. Lessons learned from this. I've done over 1,000. All right. You got to take action. You want to measure the outcomes. You want to continuously improve. I hold myself accountable with my job at my company as the retailer. I look at myself as the customer. Whenever I'm looking and reviewing data, I'm always looking at, okay, what do I need to do to continuously improve, right? And that is using the data, optimizing the process, ensuring everybody is involved really helps drive this through. And if there's problems, they boil up to the top. So that noise should come into account very quickly. Within a month or two of a pilot, whoever had the noisy experience, that should have came forward in that data set to where you could point, hey, I've sent 5 trucks out of 10 and I didn't find a leak. What's going on here? And I've had retailers tell us that for sure. Sometimes it's just sensor issues. Sometimes it's, hey, our software doesn't look at that correctly. What's going on here? Roll trucks. One thing that I had a problem with back in, I don't know, a few years ago, people just looking at the data and never rolling trucks. And if you don't roll trucks, it doesn't change anything. This software is worth nothing without a truck rolling and fixing something. There's certain aspects you can change with software, but you've got to go out and make improvements in those facilities. And the small blurb I put in there around condition-based maintenance, it takes a little time, because whenever you go out and look at this, our technicians tell me, hey, I don't look at condenser fan cycles. Hey, I don't look at delta T's, until it's too dirty, right? You've got to train and train again, and you do it with the data so that they understand why they're taking the actions. Then all of a sudden, everything falls into place. So, like I say, trust, measure the data. Training contractors on what leaks and performance mean. One of the biggest problems we had early on was, we had contractors spending 20 hours, 15 hours trying to find a 15% leaker. They're hard to find sometimes, and especially whenever you get a 10% leaker. And what you got to do is you got to change your mentality. If I'm looking for a 50% leaker, then I can go out. I'm going to see bubbles, see oil on the floor, see all sorts of problems. Some of these really small leaks, I mentioned it earlier in the presentation, where you got to shut a case lineup down for 30 minutes, let it set, and then use your handheld leak detection system to go out and see which case is leaking. Then you got to go in and find out, is it on the valve, on the coil, on the piping, etc. Feedback is very important. Don't leave people out. We report out. I report all the way through our CEO to all results on leak reduction, on service savings, productivity, the whole gamut. And I advise you guys to do that the same. You should be the one that's reported to, but share it in your organization, because the store managers notice a change when a technician's showing up and they don't know they're there, or maybe you're going to let them know that they're coming. And at the end of the day, it's good to know, hey, this is what we're doing. This is how we're improving, and showing them the results. And I always say, if you prioritize condition-based maintenance, your emergency truck rolls will drastically reduce. But you have to prioritize condition-based maintenance from September through May. Last but not least, leak reduction and condition-based maintenance is about change management. All right. It doesn't need to be difficult. It just needs to be managed. Okay. I look at people and I feel sorry for retailers. Heck, I feel sorry for our industry. We're plagued with all the problems I talked about at the start of the presentation. What I always think through, just take a breath and then use the data and develop a process and carve out a little time and make it standard. If you do that, you'll continuously improve. Okay. And it'll get easier. Because what I had a lot of retailers tell me at the beginning, this is just more stuff for me to do. Actually, this can reduce the stuff that you need to do, because the emergencies will reduce, your leaks will reduce, your compressor failures will reduce, and you'll be able to get more time instead of chasing every emergency under the sun. One thing I always tell retailers, whenever you're doing this, energy should be focused on in parallel. Okay. Everybody starts with leaks because that's the regulations. It's a big cost. But in the winter, September through May, why not, whenever you're going out and doing condition-based maintenance, do energy-based maintenance while you're there? Improve those assets, optimize those settings, follow and focus on both aspects, and you're going to get a bigger payback. But just condition-based maintenance alone will help pay for itself. And you'll get energy savings with that, but there's lots of other stuff you can do with the data. And then I already talked about this one too much. Manage the process based upon the time of the year. In the summer, I will tell you, there's certain things you just do not have time to do. So we reduce the priority on condition-based maintenance June through August. We just know better. All right. and you just roll trucks on the critical leaks and critical compressor issues. Other than that, we let it rest until September, because you're trying to yield fruit June through August by working September through May. Because if you level that curve out on demand, you're going to help your technicians out, you're going to help your store cost out, and you're going to help your headaches out. All right. And engage across the organization and get buy-in, all the way down to store personnel, food safety, energy management. Get people involved. Don't keep it in a corner. You want to let everybody know what you're doing, because it affects their side of the business as well.